Bismillahirrahmanirrahim. Today I am going to prove that integration ax plus b to the power n dx equal to ax plus b to the power n plus 1 divided by n plus 1 times a plus c where n not equal to 0. For this, first we suppose that u equal to ax plus b. Now differentiate u equal to ax plus b with respect to x on both sides to get du divided by dx equal to d by dx times ax plus b. So du divided by dx equal to apply derivative with each terms d by dx times ax plus d by dx into b. So du divided by dx equal to a times d by dx into x plus d by dx into b. So a times derivative of x with respect to x, which is equal to 1, plus derivative of constant equal to 0. So a multiplied by 1a du divided by dx. So we can also write this in the form of du equal to a times here dx is divided. If we shift to the right hand side to get a times dx. So du is equal to a times dx, but here we need a dx. So therefore divide both sides by a cancel. So du divided by a equal to dx. Now integration ax plus b to the power n dx equal to integration put the value of ax plus b equal to u to the power n and dx is equal to du divided by a. So this implies that we can also write this in the form of 1 by a times integration u to the power n into du. So this implies that 1 by a integration u to the power n du. So this implies that 1 over a integration of u to the power n is equal to u to the power n plus 1 divided by n plus 1 plus c. So this implies that u to the power n plus 1 divided by n plus 1 times a plus c. So here put u is equal to ax plus b, which is we supposed. So this implies that ax plus b to the power n plus 1 divided by n plus 1 times a plus c. So integration ax plus b to the power n into dx equal to ax plus b to the power n plus 1 divided by n plus 1 times a plus c, which is right hand side, hence proved.